So I was showing the Kitty Hawk Heaviside, which is an air taxi that is electrically powered, that old chum Chris Anderson has recently joined that company as COO when they purchased 3D Robotics, which you remember me probably from quite a few years ago using Go, as it just so happens, to fly a 3D Robotics Iris drone. So anyway, very cool stuff that is happening in electric vehicles of the sky. I just think that is so cool. All right, so this is the video, if we can see it, of, there we go. This is the Heaviside, which is the Kitty Hawk air taxi, and it's a pretty interesting looking vehicle. You can tell that they've got some different design concepts, and some of the specs that they have been sharing are just outrageous. So I'm pretty excited about that. So last Tuesday, if you were on the internets, I was fortunate enough to be interviewed by my friends at Microsoft on their awesome weekly stream Hello World, which is on Microsoft Learn TV. So you can check out the recording that is right now already up on Channel 9. And if you want to get information about some of the things we talked about, you can go to aka.ms/hello-OSS. And awesome human being and Go friend, Erin Whistling, has been doing a great job with this show. And I was really lucky to be invited on for the season finale. So does that mean I'll be coming back as a recurring character next season? Or I don't know. Anyway, though, it was really fun. They have a lot of cool stuff that they're doing. And it was really great to share with them some of the things that we've been up to with TinyGo. So on the other side of the world, in Chicago, which just so happens to be my old hometown, there was at the Chicago Gophers meetup at actually it was some hours later. I think probably midnight in European time. Anyway, Tobias Thiel gave a remote talk about TinyGo, showcasing some of the cool demos that are in his book that just came out, the first TinyGo book. And so I didn't get to see this video yet because I couldn't figure out where it actually was online. Supposedly the video of the talk was there, but I haven't gotten to see it yet. Anyway, really looking forward to checking that out, and super cool stuff happening all around the world of TinyGo. So I brought some toys with me, but we'll kind of get into that. But I thought before we did that, we should try to finish up a couple of the loose ends, some of the long story arcs in our own extended first season. And so I think maybe we'll start with ¿cuántos minutos tienes? The aproximamiento de demo.
5, 10.
Okay. So we'll start with Manuel, who's been working on the project cow detection using machine learning, TensorFlow, OpenCV, and GoCV. So I'm going to put my mask on because we got to see some really cool demos last time showing some of the training systems, and apparently this time we've got some actual code. Ooh, let's find out. Let's see if the homework's been worked on.
Hi,
It's your
Ron.
final grade depends on this.
Oh,
Hey,
my
how you doing?
Thank you, Ron.
So I still have this computer plugged in. I think if we just unplug it and plug it back in, it won't be too bad.
Yes.
Oh, no
No,
problem.
no
No worries. Do you have HDMI?
Yes, but I think it's on the other side.
Oh, of course it's on the other side.
It's always on the other side. Yeah.
That's one of the great rules of life. The input you need is on the other side. All right. Cool. So
Right.
yeah, tell me what you've been up to.
Well, if you remember, last time we talked about how the model didn't really detect that rate in video source, let's say using the webcam.
So just to recap.
The recap.
So last
Yes.
week you showed your trained machine learning model,
Yes.
which you had retrained using some source images of cows,
Yes.
and you were able to actually execute the model on your computer using the remote server of, what was the company whose training services you were using?
No, I didn't use their training services. I used their labeling system
Ah, okay.
just to save some time. But I executed in OCV, and
Oh.
we got to see that it didn't really detect much.
Okay.
Just because it's not really a final model, let's say. It had only 300 images.
So that's a very small number of images.
Yes.
Okay, so then what did you do next since the last time?
Yes, so what I did next is I wrote some code in OCV to intake still images instead of a video source, just to check if, well, in still images, as we saw previously in TensorFlow, we could actually detect cows. So maybe this can also detect cows in OCV, right? Well, in
Makes
OpenCV.
sense.
Yes.
Makes sense.
So let me walk you through the code. I basically took the code from the DNN detection module and I changed some things. I also took some code from the show image module just to see how to actually, well, it's actually a wrapper of OpenCV, but how to actually read the image and show it in the frame instead of just in a for loop.
I forgot to show you that.
Yes, but no
my
problem.
bad. But
I found it.
But you found it. That's good. That's good.
Yes. So, well, I changed how this model works. So, main changes were, yes, setting a test directory. So, the first, if you remember, the first argument of the DNN detection model was the device, right? So, you set that
Which
0.
camera to use?
Yes, which camera to use.
Mhm.
So, I changed that to intake the image that you want to run the predictions on. But the rest of the arguments stay the same.
The model to use, the configuration file.
Yes, basically.
And then if we had some hardware acceleration set up,
Yes.
we'll do that in the next time.
Okay.
Well, I guess that depends on how good your performance is with the CPU.
Yes. Not great. But let's see. Yeah, so the first change is setting up this object with the IMRead to read that image with the IMRead color.
So you're reading a color image from a file on disk.
Yes, I have the files right here. So this is the image detection module that I created. And I just input, some images just to test that it works.
Sure.
So we create this object. We test that it's not empty. Then we create a window. And we...
That way we can see the results.
Yes.
Mhm.
And we read the net. This is all basically the same as in the DNN detection module.
Mm-hmm.
Just if you recall, after all of these setups for either Cafe model or TensorFlow models and all of these variables, if you remember when we perform the detection, we actually have a for loop, and then it is always running a blob detection for each frame of the webcam, right?
Mhm.
So we don't need that here because we only have one image. So
we only have to do it once, basically.
yes, basically.
Makes sense.
So, but it's the same thing. So we have a blob from an image which is 300 by 300. This is important because this is the resolution where we should have trained our model, just to make sure that the predictions when we run them on the image make sense. So if we train the model on 300 by 300 images and we input an image with bigger resolution maybe, then the model may not predict that well.
Makes
so
sense.
we have to make sure that that's right. Then we just set the input and forward through the net. And then we have the perform detection function, which is basically the same. And if you see here, I have the for loop where basically I'm doing the same thing that is in the DNN detection module, except now I'm using IMShow for the image.
So it's just showing the image that's already been processed, but it's not reprocessing it each time.
Yes, it's just showing it because if you don't input this for loop, then it shows it for one frame and then it disappears.
Makes sense.
but the perform detection part is still the same. I'm just printing the confidence, and then my threshold is 0.3, just because I want it a bit lower, just in case, well, because the model is not that great. So we can run that.
And then this code here is drawing a rectangle around what
Yes.
it thinks it recognized?
Yes, it's the same code, and I added something here at the end using the put text function from OpenCV. Just to write, well, I'm writing cow just because I know it's a cow, but if we had several classes, we could input them any other way, which is more efficient. But it's basically printing the confidence besides cow in one of the corners of the detection, just to see, okay, this is a cow and it predicts with 90% accuracy, let's say. So
Useful.
yes, I mean, in Python and in TensorFlow, a lot of these models do have this, and I thought that it was weird that this one didn't have it, but it's not a problem. You can just do it like this. So, for example, we can run this pretty easily. We just input, instead of 0, which was our webcam, we just input a path to an image. I have them right here, so I can just call them because I'm in the right directory. And then I input the inference graph and the configuration file, which are the ones we need for prediction.
And those are the ones that you downloaded after you've trained them.
Yes, exactly. And I actually have to change this because, spoilers, I trained a new model.
Oh.
And it's not that one.
Nice.
So this is the old model, and let's see how it performs. Oh, why did it crash? It crashed maybe because it didn't find them.
It was not able to open the
Yes, because I maybe...
move the path.
Yes. Oh no, I know why it is. It's because it's not called config for this one. I think it's called test. Yes.
Without
So-
autocomplete, I couldn't do any work.
Yes.
Tab autocompletion is the best invention.
Yes.
Oh, wait. It's a cow.
Yes, and it doesn't detect,
Oh,
right? Maybe if I lower the confidence even more, maybe this will work. So the model is rubbish, let's say. Oh, well,
The whole thing is one giant cow.
there's at least one cow here, right?
Okay.
I mean, we can agree on that. There's at least one cow. So
With a confidence of
0.2,
Of 0.2.
so really, really bad. This is one of the things that had me intrigued because, well, as you saw in this image, we have a 0.2% detection precision. But when I ran this test, if you remember in TensorFlow, the predictions had a higher value. So I thought, okay, this is really weird. Why are the predictions with the same model different? Well, basically, I read a lot of documentation about this, and my final conclusion, let's say, is that the way TensorFlow works, not just with the object detection, but the way the inference works with TensorFlow, and the way OpenCV does its inference, probably has some changes in maybe the output layers or something of these models that I couldn't control, or maybe I could control if I had more time. But I think that's the reason why these changes are. But anyway, I think it's even better if we run inference on OpenCV, just because it's a lot faster than inference on TensorFlow. So TensorFlow is really slow. For our purposes, OpenCV is the way to go.
For offline processing, I've used things like TensorFlow Server,
Yes.
but not generally for real-time type processing.
Yes, for real-time, OpenCV is a lot better. So, okay.
But, one thing I was thinking
Yeah.
was I had to bug in some code that used this same pattern before, and it turned out that the problem is the code that turns the image into a blob.
Yes.
So that
So-
function is a little...
This one, yes.
Yes, that's the one. So it has a number of different parameters to modify the different values as it's constructing
Yes,
the
to
matrix with the
subtract
blobs.
the mean and swap RGB, because I think OpenCV uses BRG, I think, or
That's correct.
it uses another channel.
It's the same, red, green, and blue, but it's in the order blue, green, and red.
Yes.
For historical reasons having to do with a thing called television.
Oh,
I know. What's television?
yes.
It's a a thing that's sometimes on in bars when you walk through. But the bug was actually, I believe the last parameter is to crop or not.
Yes. Yes, I think so.
So
it's false.
what I was doing was I was accidentally stretching out the image
Oh.
because the
yeah.
aspect ratio of my source image was not perfectly square like the trained images in what I was trying to use for the object detection. And so when I realized that and I fixed it so that it was the correct aspect ratio, the recognition improved dramatically.
Yes, that does make sense.
And it was just a very easy, the mistake was a very rudimentary mistake. And I looked at this code so many times and I didn't realize it until I think maybe it was, in the output. Just finally one day it occurred to me to look at this parameter and I realized I'd been doing it wrong the entire time. I changed it and suddenly the recognition improved a lot, as you might imagine.
Yes.
Anyway, I just was thinking that you probably don't make those mistakes because you're a trained professional and I'm just a programming guy. But yeah, but anyway, it was just a thing that I was thinking about. So tell me more about what you did next.
Yes, so I also created a program with OpenCV in Python, let's say. So, maybe I can open the folder and then I can show you.
To compare the results to see if you're getting the same thing.
Yes.
Makes sense.
But this one uses the webcam. It's using OpenCV, but it's using the webcam, but in Python instead of Go or anything, which actually should output the same. Because
it should do the same thing because it's going. If not, then it's a bug somewhere.
Yes. It actually worked, I think. But now I have to remember how to actually call it. So Control R, which is really useful.
Oh, yes.
And it's here. We don't have it. So this is Python for the webcam detection of the OpenCV, which is the name of the Python script. Then we input the model, which is in the 50K model folder.
So that's the same model?
Yes, it's the same model as before.
Very good.
The config file, and then we can even input the confidence that we want. And it didn't work because...
Of the same reason.
Okay, I don't know why this...
Because the file was moved. It was the same error, but with a different message,
yes.
Probably.
No, it's not because it's moved. It's because when I read, this is trying to do it with the new files from the new model that I trained, and I changed the name of the config file to test. Well, the name wasn't the same, so this is why it doesn't work. But okay, and it doesn't detect anything because
neither you nor I are cows.
And the model is rubbish. So both things.
That's two problems.
Yes.
But even if the model was great, we're still not cows.
Yes, that's true. I mean, I hope it doesn't detect that I'm a cow. That wouldn't sound fine.
I've been trying to work out, so.
So this is what I did regarding scripts. And then, as I said before, I retrained the model. I uploaded a lot of more images.
More than 300?
Yes, I think I have about 900 now, which is a lot more reasonable.
And you've labeled them all as cows?
Yes.
Amazing. That's a lot of work.
Yes, it took a long time, and I think I may need even more. I don't really know, but that was the new model, so we can test that as well. I just have to move from my directory. So this is in this direct. Yes, but that won't work because I have to go to the actual detection module, which is here. I have a lot of folders, so I get lost pretty easily.
That's why I have so many tabs. If I have to restart my computer, I had to restart my computer last night, and I don't know what I'm doing now.
Yeah.
Or what I couldn't have been that important, or somebody would ask me to do it again.
Yeah, okay, so this makes sense. This will run inference on images2.jpg, which is one of the images I had, using the No, this is not the 50K model. Why? No, because this is the 40K model actually, because it took a lot longer to train. Instead of, let's say, I think it was about 20 seconds every 100 steps, and this model took about 40. So double the time. So this, and now it's called config, so it should work. And error opening, yes, that's because I'm not using the correct module. I'm using the DNN detection one, which is the webcam one, and I'm trying to use it as the image detection one. So I have to move here, and now it should run on an image. Oh, well, it's a lot better.
It's very certain this time.
Yes.
But in similar fashion, it knows that there's a cow-like image within there, but
Yeah.
it's not necessarily trying to track each one.
Yeah.
Probably it doesn't have enough visual information.
Yeah. Yeah.
Or maybe
I don't
it's
know.
something to do with the color of it.
No, I don't think so, because in the validation part of the training, it worked reasonably well. It may have to do with what you said about cropping the images correctly, maybe the resolution, or even maybe the training parameters. Maybe I have to look at them better. Maybe I have to train and evaluate at the same time and have a cutoff point or something, just so it doesn't overfit. Because I think I haven't tried it.
I was just
tried it
noticing the
yet.
color palette of that image is there's not a lot of contrast between the colors of the sky and the colors of the cows are not such a high contrast.
Yeah, in that one it's difficult, but
Do you have some other sample images?
Yeah, I do. I wanted. Well, let's try that first. So if we go here, I think I have. Well, I have a lot of images, but maybe one of them is images 5, I think. So yeah, well, basically the same thing.
But even just to the untrained eye, it looks like there's more color contrast.
Yeah.
But it's still doing, I mean, it's a small image and maybe it's not trained to recognize features of a cow, but just entire cows.
Yeah.
I mean, it's obviously, so do you have a negative example of an image with no cow that we can try with this model?
I don't, but that's one of the things I wanted to show you, is that maybe this model is overfitting a lot, because when I tried, well, we made that joke before. I hope the model doesn't detect me as a cow, and I think it will, just because when I run it with the DNN detection one, so I have to basically change this parameter from the JPEG to 0, just so it takes the camera. Oh, I'm a cow. Everything is a cow.
I see the image, but
Yeah.
it doesn't, but I don't see cow.
Yeah, that's.
So maybe it's maybe one of the other classes that it's able
No,
to
I
identify.
think it's a cow. It's because I was really lazy. Sorry about that. But when I had the... Oh, no, this is the DNN detection one. So this one doesn't have a label.
Ah,
I haven't tried it with labels yet.
but I believe you that it thinks we're cows.
No, in the other one, what I wanted to say was that in the image detection one, I cheated a bit and I said, okay, move 3 pixels to the right and 3 pixels down, and then put the label there. So if the label is big, then it may show up correctly, but if it were smaller or something, maybe it would be outside of the box or something. There's definitely a better way to do it, but just for testing purposes. So yeah, this model is also rubbish.
But
Well, it's better than
better.
Yeah,
It's better.
we're right
And
there.
it's faster.
Yeah. For
So
sure.
do you think that it can now keep up with a frame rate that's, you know, what frame rate would you estimate that you think it could keep up with?
I mean, I think maybe 24 FPS or something, maybe. Yeah, I think that's where the SSD models move around. So I think it should. I mean, it's all about training more and more and more, and having even more images.
Because I have a demo that I've shown that takes a type of drone, a DJI Tello drone, and then I would use it for facial tracking. Once you've got it so it's not too overfitted, we could try that with some video that we maybe capture. If we have some video flying through some cows.
Yeah. Actually, that would be great, just to test if the model works or not.
Exactly. So we just need, by next week, we just need a video.
Yeah.
And it doesn't even have to be flying. It could just be like walking through. I'm sure we could find some video on YouTube of.
Yeah, there are some videos of cows.
Or we could even get, Lucia or somebody who actually knows cows.
Yeah, and we could test it outside or something. Well, with a video first.
Well, let's get the video, and then only then will we take the drone out to try to real-time track the cows. I guess that'll be the finale.
Yeah.
Once we have it, it seems like it's working fast enough.
Season finale.
Exactly. The big cliffhanger is like, will the drone crash or not?
And will it detect cows?
Well, yes, of course that. Well, cool. It looks like you've made some really great progress.
Yeah.
So what's the next step?
So I think the next step would be just looking at the training parameters and trying to train a better model. I don't know if 50k steps is the right amount. I should think so, but maybe the learning rate needs to be lowered or something. Also,
you need some other animals to make sure that there's no false positives.
Yeah, well, I mean,
right now it's obviously recognizing us because it's overfitting.
Yeah, but it shouldn't really need that many, let's say, background images or negative images, just because there's a part of the TensorFlow workaround that you do when you train, which is a hard negative minor, where it basically takes the image and, this is the actual cow. So from the parts that are not cows, they take those as negatives, just so it lowers the false positive rate. So it shouldn't, in theory, but we have to see.
That works pretty well for some other types of technology, too, like anomaly detection, for example.
Yeah.
Interesting stuff. Well, very cool. So, I look forward to seeing the next version. And let's see if we can get a video and actually, test the frame rate.
Yeah.
And one of the demos in there, you can increase the delay of the weight so that it doesn't feed too many images or frames to the model if it turns out that it can't keep up.
Yeah.
Now, there's a couple ways to adjust that frame rate so we can figure out, what's the maximum.
Okay, great.
Cool. Well, great work, man.
Thank you, Ron.
You're doing awesome.
It's a pleasure.
This is really fun. Cow vision, 21st century.
The future.
Yes. The future is the same as the past. It's all about the cows. That is awesome. Wow, that's really cool. Computer vision and, let's see, go back to the main. Yeah, computer vision with all of the trimmings is something that is a lot more interesting when you have some machine learning technology to apply this kind of recognition. Suddenly it could become very interesting. Cow avoidance, like you don't want to crash into them, or cow recognition. Whose cow is that? Yeah, very, very cool. I love it. All right. So now let's go to the final step in the amazing story arc of Lorenzo learning to TinyGo and actually substantially improving upon the whole experience by putting the hardware together properly and helping to identify all the bugs. Hey, how's it going?
I'm fine, thank you.
Good to see you, man.
Good to see you too.
Yeah, so last week I was just totally amazed at, let's see if we can jump over to the...
We cleaned up a little bit, maybe on that camera.
Oh, you cleaned it up even more? Oh, well, let's go to the micro. Because that's... Is there enough light?
I don't know.
Not too much, no.
Do we have to plug it in to light it up a little bit? Oh, no, it's okay.
You prefer a red light or maybe a green light?
Beautiful, nice atmosphere. It looks like a jungle. I don't know if you
Yeah, blue light. Oh, thank you. That's
looks good.
Yeah, so you did an amazing job reorganizing all of the cables.
Yes, it's much better. You can easily troubleshoot and yeah, and also see a pin layout to find out where to plug in without having to
Oh,
look at the
we're on the
screen.
wrong camera. No wonder. I thought that looked a little odd. There we go.
Thank you, bot. Go for.
Yeah, that's really cool. So, just to reiterate for anybody who maybe wasn't around for the whole story arc and you're just tuning in here for the final episode. So, what this is about is taking the information that was used for the workshop at GopherCon 2019 and then revamping it all, which is a multiple step series of lessons to take an Arduino Nano 33 IoT microcontroller and turn it into this cool sensor device that adds more and more sensors. And then the final step, which is step 7, is the part where we actually connect it. We take the thing and we turn it into an internet thing. And the way we do that is by connecting it, of course, to the internet. I mean, otherwise, not much happens. So let's see if we can. You need the. We unplugged that for
I think my
Manuel's.
laptop died.
Oh, you
Let's
need
see.
you need batteries.
Let's see. Oh no, it's okay. Just fell asleep. Hold on, this.
Oh yes, let me move this. Yes, so.
Look at this. Now it's. We're having the dial working as promised. So there is, and the LED as well. No, not the other one. So maybe we have to reset the connection.
So if we just take a.
No, I think. Let me see. Okay, no, we changed the software, so we only have now the working display. So if I press the button, you can see in real time maybe it's over here.
I think there's a little delay, possibly, and there we go.
Yes. So we can see this one is working, and the numbers that show up on the display are actually representing the status of the potentiometer.
Going between 0 and 65535, which is the highest value for the 16-bit analog to digital converter. So we just jump over real quick again to the code so we can see what we're looking at. So the step 7, which is this final step here, is we can do it on your computer. That's good. I'll jump over there. So step 7, if we go to the actual code.
Okay, let me. Okay. Wait. I am having some issues. Okay. Sorry about this.
Every time I use Windows, I'm like, oh, how do I copy and paste? Oh yeah, Control C.
I don't remember. Go for it.
And then it's under exactly Arduino, or sensor Arduino, actually.
And it's step number 7. Okay. Step 7.
.go.
It's direct.
It's in the directory.
Sorry.
Well, no worries.
So
So I'm surprised you haven't tried to install a slightly better editor.
no, I have it, but it's I usually use the PyCharm for Python, and I have also the other one, which is very.
I use VS Code successfully on Windows.
I have to switch to it. Yes, it looks very nice. It's called main, right? Notepad main. Okay.
All right. So let's take a look and see what this is doing. So it looks like it's doing all the same exact things. As, brings in all the same packages as the step 6 did. Right. So we've got our different drivers for the buzzer, and then so yeah, actually, I'm looking at this and I'm realizing that there's actually a fairly sizable change that's taken place from when this was done. And that is that this example is using the SPAT driver, which stands for the ESP-AT command set. And I believe that this board has been flashed, if I'm not mistaken, with the Wi-Fi Nina firmware, which requires a different driver. So we're going to have to change that. But I believe that that should be okay because, let's see, what was the name of the event? We actually did a revised version of this for a Google event. Let me think of where the, it was, let's see, where will I find that? Probably in the same location. Let's see. So much code, so little time. Let's see. Trying to remember the name of it.
Well, maybe we can run it on your machine.
Oh yeah, GDG 2019. So it was the Google Developer Group's 2019 conference, which took place in Portugal. It's a really fantastic event. And let's see if we're still using SPAT at the time. Yes. So we're going to have to make a few changes to actually get this to work. Only because the actual firmware that's on your ESP32 compatible board is different firmware than was used for this example, which the API is a little bit different, but I bet we can figure it out. So, let's see. The easiest way will be probably, so if we were to look at the drivers repo for TinyGo, the driver that we need to actually use here to connect is called Wi-Fi Nina. And if we looked at the sample code under examples for Wi-Fi Nina, there is an example for MQTT client, which is really, really similar to the code that we need to change in the example for the GopherCon code. So one difference is you'll see that we're using the Wi-Fi Nina driver instead of the SPAT driver. And then the other one is that but we're still using the driver's net MQTT package. So this might not be too difficult of a change, but let's see if we can figure it out. So if we go to take a look at, I don't know if I should try to do this.
Yes,
probably.
Better, yes.
It seems like it might be a little easier. So I'm going to go and I'm going to use GVM to choose Go 1.163. And then I believe, I think it's under development. Yep, that's where it is. And this is the GDG 19 code. That's not what I want though. I want the GopherCon code. All right, so if we bring up Visual Studio VS Code, I trust the authors. The authors of TinyGo, I trust them implicitly. They're like my best friends. I feel like I feel like it's myself. I know them better than I know myself. Or do I? Okay, so anyway, what we were saying. Oh yes, back to reality. So instead of using the SPAT driver, we want to use the Wi-Fi Nina driver. No, it doesn't want me because you'll notice my editor remove that line. It's because Go Go FMT, which is the automatic formatting, is already installed, and every time I save the file, it runs it, so it'll automatically reformat my file for me.
Okay.
But that isn't always what I want, right? Like in this case, I need to say Wi-Fi Nina device, I believe. And let's go and take a look at the sample code we were just looking at to make sure we get it right. So it uses the SPI interface instead of using the UART. So that's one really important difference right there. Right, so we're not going to need this UART anymore. Instead, we're going to use the Wi-Fi Nina, which uses the SPI interface. And so we're going to define that pin. And the adapter is still the Wi-Fi Nina device instead of the SPAT device. We have that. That's good. So that's okay. So we don't need to configure the UART anymore now. We need to configure the SPI interface. And so we can do that. So instead of configuring the UART, we configure the SPI. And then we want to configure the adapter for the Wi-Fi Nina board, and it's very similar to what we would have been doing for the SPAT, because they have a pretty similar API. But they're just different enough that we don't want to just, so that if we just compare them to make sure that we're doing it right. So this is saying, so we used the SPI configuration to configure the serial peripheral interface. And then all the other code is the same as the previous example. We turn on the I2C interface by configuring it so we can use the display, the analog to digital converter, the PWM so that we can make the beeping sound. So the only difference here is that we're going to use the Wi-Fi Nina adapter, and then we have to configure it, just like any of the drivers. We say the name of the driver .configure, and it will set it up so it's ready for use. And then I have this function I wrote called connect to AP, which is a little different than what we're doing here. Right? We call this connect to ESP instead of connect to AP. But it probably does the same thing, which is connecting to the access point, right? So let's go take a look at what connect to ESP does versus what connect AP in this function, which is in the same file. We don't even need to. So connect to AP, what it's doing here is it's almost doing exactly the same thing, right? If we could actually, we are going to connect to this network, and we're going to set our passphrase, which we do differently with the SPAT interface. It calls this connect to AP instead of set passphrase. So we need to actually unify the API between the SPAT driver, the Wi-Fi Nina driver, and another Wi-Fi driver whose pull request is actually waiting in this repository right now, which was just contributed just over a week ago by Sago35, which is support for the RTL 8720DN Wi-Fi chip, yet another Wi-Fi chip. And this is going to have yet a different API. So we need to make it at least so that all the APIs are the same, because right now it's really, really hard to just switch between them.
Yeah.
And the idea is that we want to be able to switch between them. So anyway, let us continue. So those are some differences right there. And so it's going to connect for us and then give us a message when we're connected, and then display the IP address and then return. And the purpose of this is just to connect to the access point that we have here in the studio. So let's go back to the original code again, or the modified code, rather. So we're going to connect to the access point, and then after that, I think most of this is going to be the same. If we go and we take a look at what the actual MQTT part is doing, once we've connected to we can just call this connect to AP, just to keep it the same. and connect to ESP32. Connect ESP32 to access point. It's not an access point, it is a client, so it needs to connect to the access point. I think it was called connect to AP. Oh, that's right. Actually, I already added this other function. So we can just remove this. Wait, am I doing this right? Oh, it's supposed to return a true or a false depending on whether it succeeded. That's what the problem is. So if it fails, it'll always succeed. So we'll just say return true. And we have to return a value, a bool. All right, now this should actually have a better chance of working. Okay, good. So if it connects, the blue light will turn on, and it should, otherwise it will, oh, and we actually removed the, did we? Let's see. At one point I had it so that it would display that message on the screen. And in fact, you'll notice we're not actually using, oh no, we are using the display. Where are we using the display? Okay, so no, I didn't remove it. Okay, that's good. I just wanted to make sure I didn't totally remove it. All right, so we've almost got this done. So now the part where we actually connect to the MQTT server, to do that, what we have to do is, here we go. So first this is using the same interface as a very commonly used package, which is actually created by the Eclipse Foundation called PAHO MQTT, but for Go.
Yeah, I had used the one for Python on the
Yes.
client side.
Yeah, I mean, these are the official libraries from the Eclipse Foundation. They're also the maintainers of Mosquito, which is
It's the embedded one.
the MQTT broker that a lot of people use. So, so because this package requires some operating system, and because TinyGo has no operating system when it executes on a microcontroller, we couldn't just use this package by itself. However, we were able to use the important part of it, which is the actual definition of the MQTT packets that are used for the protocol. It's a TCP-based protocol to communicate. And so we could just use this. We're actually using the real package in the driver, but we're not able to use the entire package. And the reason for that is because it has some expectations about the way that the operating system should be providing some of the networking capabilities. And in our case, we're using that other chip that's actually built in, right? And we're communicating it with either with the SPAT driver, a serial protocol, and with the Wi-Fi NINA, a SPI-based protocol. So it's not using like operating system networking calls at all. And that's what the normal PAHO package expects. So that's the reason we couldn't just use it by itself.
Right.
But we could take pieces from it, especially the most important ones, and then use those in order to put everything together as far as what we need to communicate. So it's still the same basic principle, which is we're going to create an option structure whose purpose is just to hold whatever. If we had some specialized options that have to do with the MQTT quality of service or keep alive times, this is where we would set those. But I don't need to change any from the default. So then we add a broker to it, which is whatever server we're going to talk to. And we set our client ID to tinygo-client and then some random string. This is because most MQTT servers will, if they get a client connecting with the exact same ID as one that was previously connected, they'll disconnect the old one and only allow the new one to connect. That way they don't get duplicates. So this creates a random string, and that way if you and I both at the same time try to connect to an MQTT server, it doesn't kick one of us off. We found this out when doing the workshops, that if we didn't have a random string, everybody was stepping all over their own connections, and the Mosquito MQTT server would say, oh, kicking you off because here's a new one. We couldn't figure out what was going on at first. So anyway, so we set that client ID. We'll turn the blue light off, display a message. Then we'll try to connect to the MQTT server. And then we'll go on to, if that works, we'll initialize the display, handle display the same as our code from before. Now, the only difference between the code that we previously had and this code is after we get the value of the dial and the button and the touch sensor, we're going to take and we're going to publish a message to the MQTT server that publishes this fake JSON. It's not real JSON, it's just text that looks like JSON. And then it publishes it, and then it'll do this every 100 milliseconds, the same as what we were doing before. So the only difference between this and what we did previously was that in addition to us reading the sensors, we're also publishing an MQTT message, but otherwise it's exactly the same. So let's find out if this actually compiles.
Yeah, we need to...
And then we'll plug it in and see if this works. But I need to see if it even compiles first, because I have not actually tested it. So if we say tinygo, we can make this a little bigger. Tinygo build, and we'll output to just test.hex. And the target is the Arduino Nano 33. Hey, I see a question on the internet about GoCV. Should it run on the Apple Silicon M1? That is a really good question. The answer is, I don't know. I don't have an M1 myself. Well, my wife does, but if I take her computer and I try to do this on it, you may not see me again for a few weeks because I'll be in hiding. I think that it should, and that's something we need to find out, actually. That's a very good question, and I'd like to know the answer myself. I think that it should be able to, but it may require a few tweaks because we're going to have to, you need to compile OpenCV with the ARM parameters on your Mac, and so I'm not 100% sure if the version that's in Homebrew for Mac, we could look at that, actually. After this, I'll take a look, because that's a very good question. Thank you, LiveHackNet, for that question, because that's super interesting. All right. Anyway, let's finish this. So we were just going to try to see if we could build this. Target Arduino Nano, and it is step 7, I believe. Yes.
Yes, it is.
All right. So, has no field or method echo. Yes, of course not. Echo. I don't know what that was supposed to do, but we can just remove it. That looks like a clever feature that even I forgot what it was supposed to do. All right, it does compile. Does that mean it works? Well, we don't know. There is one other thing, though, that we're going to have to do.
Set up the...
Exactly, we need... So,
the broker...
let's see, where is it? So there is, in fact, a file in this directory that should have the SSID and password that we used from, so I'll just kind of go back over to a different window. That way I can look to preserve our highly secretive information. So that's definitely not it, right? So luckily, though, I have a file that should do the same thing, I believe. I guess we'll find out here in a minute. Let's go back to my computer. All right. So I believe I have a file in a mysterious location called my desktop. And so if I copy desktop, I believe it's access to, sure, to step 7, access go. And that should replace it. Let's make sure it still is able to compile. No, of course not. SSID and pass. Oh, I see. SSID, pass. All right, so, Of course, it wasn't going to be quite that easy. While maintaining a high secrecy. Let's see if we can fix this here. Make it easier. Let me just do this. Oh, they're consts.
Set them as environment variables.
That's one way to do it, but probably not necessary here. We could just replace those with the right values. Okay, very good. Now we can go back to our main window. Make sure that our code compiles. No, let's see. Oh, it's because it should be named password. Probably the name of the variable. Okay. So now it compiles. So will it flash? So we could just flash this from my machine, since but I need a different cable. Luckily I have one. Right here.
Because of the problem you were. Well, at least we can flash it with that and then power it up if that doesn't work.
Okay. So, yeah, I had to actually downgrade my Linux kernel last night because I ran into a problem where it turned out an upgrade had come in which caused my USB computer CDC to no longer function. That was really annoying. All right, so we'll flash it. And it's thinking. It's flashing.
It's flashing, yeah.
Okay.
Well, we have to reset the buffer of the...
Well, you'll notice it's not actually doing anything. That's because we use too much power and the thing will freeze up because my USB port doesn't provide enough power for both the display and for the Wi-Fi. But luckily, I brought with me a separate USB 5-volt power supply. So if we just plug that in, so one of these here, and we plug this in, well, I guess we'll find out if it works.
Sorry, we configure this as a client, no?
That's what should happen.
Okay, nothing appears here. Do we have to set up the broker to get those?
What broker did we actually, what broker do we think we're using? I believe that we're using the broker that's just on, so maybe we need to not use the SSL version, but instead just use the regular MQTT protocol, which I believe is TCP, and make that, I believe it's 1883. We can verify that quite easily. Yes, it is TCP test.mosquito.org, port 1883. So this is actually the Mosquito test server. Yeah, I see
TCP,
that.
You misspelled it. Yeah.
Thank you. All right. So this is actually the Mosquito test server, so we'll have to plug it back in again to flash it.
Okay.
Try this again.
Flashing now.
Okay.
So what should we expect from?
Well, the first thing it should do is turn the, it should be trying to connect to the Wi-Fi. And
Do we get any?
I'm not sure if we actually
notification?
will see any notification.
Because it might take a while. Well, but we probably better plug it again.
Well, hang on, but let's wait and see if we can,
Okay.
let's just see if we even get anything to happen here with, okay, it's trying to connect.
Okay. So
Maybe we don't have the right SSID and password. Or maybe we just didn't wait long enough. Because,
takes a while, I guess.
yeah, it could take a little while depending on, but that's what it says while it's waiting to try to connect, usually.
Okay, let's try again. Should we?
Let's see
Refresh.
here. So let's take a look real fast just to, to make sure I didn't mess up something with the code values, because I believe I've got the right info for the SSID and password, which is what we're passing in here to this connect to AP. And it should be using this code from here, connect to AP, which sets the passphrase, checks the connection status. That's what displaying that idle message as it continues to try to connect. And then it, okay. What's happening here? Get IP, prints the string. Oh, wait a second here. Return true. So yeah, it seems like it should have been working. So one thing we can figure out real fast is, so if we just unplug it and plug it back in, and we see if we can connect real quick. Well, but we weren't fast enough before it displayed that first message.
Reset, maybe.
No, leave it be for a
Okay.
second. Let's see if it. Let's give it a minute to see if it's gonna keep trying here. Sometimes it takes it a little while, and we do have the right. Oh, wait a minute. I know the problem. I believe. I'm pretty sure that. Is this the old info? No, that's the right info. Nope, that is it. Okay. So, it certainly could be similar to the symptom that I had seen when we were doing the workshop, which was to remove the OLED display because it just couldn't take it. But we're not seeing any feedback. Like, I believe that this code, when we looked at it before, that what should be happening here, when it first goes to, it should turn on the blue LED if it connects. We're not seeing the blue LED come on. Maybe we want to move that before that, so it turns on the LED. Oh, wait a second, hold on here.
It's blue.
We actually are doing this wrong. We're calling it twice. This is clearly wrong. We don't want to call that twice. We want to check to see if we're connected only once, not twice. Well, let's go back to so people can see what we're doing. That's just like a bug in the code or whatever. Because connect to AP here should only be calling. We should only be calling once, and it would do this connection. And yeah, if we're calling it twice, then that would be a bit of a problem because. But let's also change the LEDs. Let's turn on the LED initially, the blue one. If we connect, we'll turn it off. Otherwise, we'll just leave it on. Sounds good?
Yes.
Makes sense. So now let's go back and plug it in and flash it again. You thought that was going to be really easy. Like, oh yeah, just in and out of things. Should be like no problem. That's one of the hardest parts, is just getting things to connect. All right, so we'll give it a flash. It's thinking. Okay.
Now it's on. Well, let's see.
Will it turn off? Or will it just sit there attempting forever?
Connections are still on the same.
It is doing the same thing. But let's be a little more patient and give it a little bit longer to connect.
Let's give 20 seconds.
Because it does take, when you restart the Arduino Nano 33, there's two microcontrollers starting up. There's the main one, which is the AT-SAM D21, and there's this separate coprocessor, and it needs a chance to start up as well. But I mean, it would have already done so. So I don't think that's it. But now that we have the code right, maybe we should, yeah, let's try that. Let's try powering.
I had some issues with a bad cable, not so well, with not supplying enough power, and so these kind of problems sometimes are very difficult to understand.
Because I believe that we should be getting enough power out of the just the USB. I don't think we need to plug into the separate power inputs. But that was how I did it, because it should be using the regulator of the board of the Arduino. It should be using its onboard regulator to take however many amps it can out of the USB. But maybe it's not. Maybe to get the amount of power we need, we actually have to have a separate adapter to plug this in to the...
We can plug it from the input, but we don't have anything to do it right now.
I have a jumper cable, but what do you want to try?
No, with an external power source from the voltage in. I think I was powering mine not from the USB, but from the input pins. Well, we can do it. Probably I can try from home to see if we, with another source, we can fix this.
Because, I mean, let's just look at the code and make sure there's no, like, obvious error.
Is there some information we can capture in between connections? Let's see.
Well, it wasn't giving any error. It was just simply not actually connecting. It was saying connection status. And then repeating this idle message, you know, over and over, basically.
Okay.
That was what it was doing. And the SSID is correct. And the password. I know because I copied those over. You know, we would see the, if it's able to connect to the access point, let's just increase the length of time a little so we can try to catch that first message. Just to be...
let's flash it again.
So yeah, we'll flash it again.
Yep.
And plug in. Give it a little flash. Should tell us connecting the SSID hack space. Yep.
Yes. It does.
But it's not successfully connecting.
Then maybe we have to leave it for a while. Let's see. just a question of time.
No, usually it just means that it would have not given that message if it wasn't able to communicate with the coprocessor.
Okay.
So it's just it just makes me wonder: is there something else plugged in wrong somewhere? Normally, we would it wouldn't even get this far. But we're not seeing any actual error.
It was working before, so I don't know if there is any.
Well, no, I mean not just to make sure that we're not accidentally using a pin that's reserved for the SPI interface, as opposed to, accidentally, basically. What I mean is some of the pins on there could be used either as the SPI interface, or it could be used for, but I think those pins are just plugged in directly. What power are you taking out? Are you taking the one from 3.3 volts from D?
Yes.
That would be correct because that's a 3.3 volt and that's what we want to use to power the other one. This VUSB would be the 5 volt and we don't want to use that.
Yeah, we are taking, this is going to...
I think that in order to get, maybe we needed to plug into the voltage in and the ground from an adapter. Because, maybe it's not. So one way we can find out if that's the case is we can just go and disable the SSD. That's what I did originally. That was the reason for that. Was, let's see. Where's the SSD? Oh yes, handle display. That was it. If we don't handle display, or init display,
you want to exclude it.
and maybe even, it shouldn't, if it doesn't get turned on, it shouldn't draw any power. So if we just remove those, and we try to flash it again, if that has something to do with it, then it might work this time. In which case, I don't have the power problem fixed. Says idle. We don't have like a loose ground or anything that might cause it to complain. Because it's giving us this idle message. That means that the ESP32 is, so while we're waiting for this to, so Live HackNet, cool. You tried the installation. Yes, please do send, if you don't mind, we'd sure appreciate if you went to the Go CV repository and entered a GitHub issue that gave the error message that you ran into when you tried to install. Yeah, I think if you just use Homebrew from your M1, it will automatically install the ARM versions of whatever you're trying to install. And we can actually take a look at that. If we go to Homebrew, OpenCV, we can look at the formula on the GitHub repo that they have. Let's see, where's the formula code on GitHub? There we go. And we can see if there's anything. So yeah, ARM64 is there, so that should have worked, potentially. So if OpenCV has correctly installed, then it should be possible to get GoCV to also install, but it may require a few different settings than are currently in there. So Live HackNet, yeah, if you don't mind entering into the GoCV repository, which is on github.com/hybridgroup/GoCV, and if you don't mind entering an issue for, maybe this is you right here, right now. No, this is for somebody else who had run into some problems, which it looks like they did not actually install OpenCV through Homebrew. Whereas I see, obviously you have Live HackNet, but I would suspect that we would need to make some changes, possibly to GoCV the way that it is. It should still work, because if it uses package config, which is the way that it normally works on Linux and on the Mac, then it should have picked up those settings. But I don't know. Yeah, I'll have to wait till my wife goes to sleep, sneak in, walk off with the computer quietly, realize I don't have her password, and then, like, what do I do then? What do I do then? Like, then I'm caught. I have to go back, put it back, and yeah, well, but we'll see if we can figure that out, because that would be obviously a good thing to have. In the meantime, with all that time we were waiting and it did not connect, so it's clearly not working the way we expected. But it's not acting, interestingly, it's not acting the way I would have thought. Let's go back and let's take a quick look again at make sure we have all these, let's see, the MQTT examples is what I'm looking for, not the, so if we go down there, under Wi-Fi Nina, MQTT client, and so let's just take a quick look to make sure that there's nothing completely obvious. So still using the SPI configure, which we're doing here in this code that's just copied. Do we need to define the SPI interface somewhere? SPI equals machine. Oh, well, that doesn't look right at all, I think. Just looking. That would be a pin, not an actual interface. That doesn't look right. Something looks off there to me. Let's go take a look at one of these other examples here. MQTT sub. Well, that must be right. This must be the actual SPI interface and not what it looks like. I closed my window, but we can actually check that out pretty easily just by going and taking a look in, oh, wait, B0, there we go, to the TinyGo. And if we just take a look in the code for TinyGo, and we look at the board files that are used for all the different boards, which are under the machine package, and we look for the board for the Arduino. There's a lot of boards. Wow, so many boards supported. It's pretty incredible. So yeah, this is not right. Oh no, that is right. It is Nina SPI is a constant which is set equal to SPI1, which should be and yeah, that should be a it certainly should have worked. But something worth trying, perhaps, would be if we go back to the, just out of curiosity, if we say that this SPI is going to be a pointer to it instead of a, by saying, using the ampersand and getting the address of, and let's just see if that, maybe, I don't think that's it though. I think there's something else wrong. But I'm not sure what yet. We'll flash it again.
Yeah.
And it is trying to connect again. But it's not actually getting an error. Usually if there's something wrong, it won't say connection status idle. So this is what happens when it thinks it's sent the request, but it just hasn't been able to actually get through. And that's this access point here. And there's no like interference or anything maybe from, just make sure everything's nice and tight, and that hopefully we haven't done any damage to the antenna or anything, which is not too likely, but it has happened. You know, if this one got squished.
Do we have another one?
I have another one, but we could maybe test it with just one of these other programs. I think I brought it with me. Oh, I didn't bring it today. I brought all my stuff except for that.
No, I don't have anything here.
No, I took the other one back because it was broken. Well, let's just take one last quick look to see if there's something that stands out here. So data out, data in, clock, frequency. That certainly should be correct. And that's what we're doing here, which is basically setting it to, and then we are defining the adapter, we're configuring it, connect to AP. Let's make sure we're doing the right things. We set the passphrase, we check the connection status, we wait, and only if it fails. Well, one thing that's a little different, I don't know if that's meaningful, is we just call the function without worrying whether it succeeded or not. Even though it should have displayed it would have displayed that fail message. We're in 7? Yeah. Okay. What's in step 6? Doesn't matter. All right. That should have displayed this fail message if it wasn't able to connect, but if it never times out, so connect to AP, it's going to keep trying until it gets through. And if it does, it should display the IP address. Otherwise, it just keeps trying. All right. We just remove some of the extra error checking, which, just to be sure. We can also try removing the actual call, which initializes the I2C interface, to see if that's drawing too much power just from turning it on. I don't think so, but okay. But it's certainly worth a try, which is not configure the I2C interface, since we're not even using it actually. So we'll flash it one last time. I don't think so. Something is not working. So one thing to try is actually just try to flash it with one of those sample programs. So if we go to the drivers, use Go 1.163, and we'll change to the directory with the TinyGo drivers in them. And if we, let's see, probably need to look at the code here real quick just to make sure we're not doing something completely off. Going back to our examples for Wi-Fi Nina, let's just go to the Connect example, which is what I used previously. And it looks like it's all pretty much the same. Yeah, well, that should have been it. Okay. And I think I have to remove these. So I believe if we just flash the connect, so if we say TinyGo, flash, target Arduino Nano 33, and we use the examples from the Wi-Fi Nina that connect. And then we go back to our oh yes. Good to note which it's doing the same thing. Something's off.
There could be some problem with the board.
That's what makes me wonder. Maybe this board got damaged, and unfortunately I do not have another one of these exact boards with me, so we can't test that right now.
Well,
All right.
we're
Going to try. So we're not finished today. We still have one more thing to finish, which is this, to get it to work, because we need to connect to the internet
yes.
for us to say we have an internet thing. So I'll bring another board with me, and I will test that as well, and just make sure that there's not something that's gotten off somewhere. And then we'll try this again next week for. So it's a 2-part cliffhanger.
Yes. Okay, thank you very much. And
Well, cool,
we will
man. I
see.
mean, you did everything looks like it's good. It's got to be something that I've done something wrong while trying to hack that code together at the last minute,
It will work next time.
not realizing that, in fact, I had, because I know we flashed this with the Wi-Fi Nina, because otherwise it wouldn't even get to that.
Yeah.
It would actually just give a terrible fail of a different kind entirely.
Yeah. Okay.
All right. Well,
Next time.
that was interesting.
Better luck.
All right.
Ciao.
All right. Thanks. Ciao.
My pleasure.
All right. Well, that wasn't quite what I wanted, but what can we do? Well, there's one other thing that I wanted to play with today. It's a new toy that actually I just got from the awesome people at Pine 64. So if you haven't heard of Pine 64, let's bring up their website. So Pine 64 is a really cool company. They have been making open source hardware for a while. If you've ever been to FOSDEM, which is the fantastic open source conference that is located in Belgium, it is a chance to drink Trappist ales and eat fried foods with your open sourcey friends. And they have, last year was the first online only. Hopefully next year we'll be back in the world of these wonderful dark beers and open source glorious madness. Anyway, Pine64, TL, who is the founder, has been physically at FOSDEM for years in a little hall, or hallway, I should say, set up with a number of different hardware hackers and open source hardware people. Really cool stuff always happening. So Pine Phone, if you've heard of that, is from them. It's an open source mobile phone. The Pine Time, which is a really cool smartwatch. And so the Pine Sol, like pencil, but Pine Sol. What happened to the... What happened to me? Well, I'll just do it. Wait for it to show up. Pine Sol. What? Not the Pine Cube. The Pine Sol. So the Pine Sol is an open source soldering iron, which is programmable thanks to its built-in 32-bit RISC-V processor. So, yeah, obviously you need an open source processor that is running open source firmware to do all your soldering. I mean, clearly you need that. Well, I needed it. And so I was really, really excited when yesterday, lo and behold, but what should appear at my door but a Pine Sol. So I looked at it in the box, and I didn't even try to plug it in because I thought I would share it with all of you wonderful people. And so this is the Pine Sol itself. So let's go ahead and open it up, see what's in here. So this is let's see if we can get a little better focus. Other way? There we go. So you can see it's very small. This is just the soldering device itself. I feel like I need a little more light. It's a little too dark. There we go. All right. So it's very small. It's got two jacks or 2 ports on the bottom. One is a USB-C, and the other one is a barrel connector. You can power it with apparently either one of those. And then up here in the front, you've got a little set screw, and then where the actual soldering tip gets inserted, which this is the soldering tip that it comes with. And, it's not too skinny and not too fat, just kind of a generally, fairly decent looking size. So let's go and see if we can screw this in, which I believe I'm going to have to unscrew this, all right, fit, but I think I need to screw it down a little. Let me see if I have a screwdriver, which I should. Generally carry many, many small screwdrivers with me for obvious reasons. Okay, so let's tighten it down a little bit. That way it doesn't just fall out. Okay, looks good, looks good. All right, so far so good. So in order to power the Pine Sol, it does not have a battery. I know you thought it was, you can't fit a battery that's actually strong enough to be able to do anything at all that involves heating up a soldering iron. So you need some type of external power supply, and that's what those 2 jacks there are for. So you could use like a not high voltage, but a higher amperage 5-volt battery, like one of those big heavy ones that you use to charge your modern telephone. That's one option. The other one is you can use an external power supply of some kind. Let's go back to the other camera, because that way we can see this a little bit better. Because I'd like to solder something. I don't actually need to soldering anything, but I just want to. Because, I mean, when you get a brand new soldering iron, you have to solder something, right? So here's the Pine Sol. I mean, the first thing we got to do is power it up and just even see what it does, right? So I brought with me one of my many power supplies. This particular one is a 12 volt, I believe it's 7.5 amp. I use it for powering LED lights that are really, really bright on some occasions when I have called to do so, which is to say, I don't even need a reason. I just will do it. So let's plug in the power supply. And then let's plug it into the soldering iron and see what happens. Okay, oh, something came on. There's some lights. So it claims that, okay, that looks like there's two options. One is to turn on the heat. I haven't read any of the documentation. I have no idea what I'm doing, but this is awesome. So it looks like the top button turns up the heat and the bottom one goes to like a menu option. Let's see what that does first. Okay, so it says power source DC. I don't know if you can see that in the camera. On this little cool built-in OLED display. And it says that it is disabled. The power limit is disabled. Power source DC. QC voltage, 9 volts. Soldering setting. Sleep mode. User interface. Ooh, what does that do? Temperature unit. Celsius, yes, of course. I don't want Fahrenheit, I want Celsius. Display orientation, right or left, I'll leave it on right. A, automatic. L, left. All right, good enough. Display orientation. Cool down blink. So the RISC-V microcontroller's firmware apparently will automatically cool it down if you put it down. So that's good. That way it doesn't burn anything down. Scrolling speed, I think that's good enough. And reversing the plus and the minus keys. I don't think I need to do that. All right, so let's go back to, oh, there's advanced options, but let's just get out a couple of more accessories first and see if we can actually use it to solder something. So I got a little tiny portable soldering iron holder. Didn't really need it, probably, but it just looked so cool. I mean, you need something to... are those lights? Yeah, you can see good enough. Well enough, I should say. So you need something to rest it on while with the hot tip, or else it's definitely going to burn something down, right? So let's get some solder, which of course I have, always, lots of solder. And let's get something to solder. What should we solder today? Well, actually, I did have something to do, which is I have one of my Raspberry Pis here. One of the Raspberry Pi Pico boards, and I have a bunch of them, not a bunch, but a few. So I wanted to solder some more pins on it so that I could plug it into a breadboard and use it for some things. So yeah, let's go ahead and do that. So I'm gonna put in my header here, break it off in just the right spot, and we'll have to put some headers on the other side, that way it stays even, which it happens to be exactly the right number of pins on both sides. Very good. So let's, can we see this? It's not the brightest, but it's probably, oh, here. I know. It's a little bit brighter over here. Yes, that'll work. All right, so let's move the cables out of the way so we don't light them on fire the minute we turn on the soldering iron. And so we got the solder, and I've got the board that I want to solder right here. And I'm going to get a chair so that I can get a little bit closer. Otherwise, I won't do a good job, and that's kind of important, right? I mean, this is not soldering for soldering's sake. I'm taking one of my precious supply, one of my oh so precious supply of Raspberry Pi Pico boards, and soldering it together. All right. One thing that is sometimes helpful is to use a breadboard, but if you heat it up too much, then it will melt. And then you have one less breadboard. All right, let's see what happens when we turn on the heat. Oh, it's heating up. Wow, it really is heating up. It's got a little display in here, and it's already at over 150 degrees Celsius. 200 to about 225 Celsius. So that's probably quite warm enough for us to solder. Let's melt a little solder on the tip to see if it in fact is hot enough. It's over 300. Oh yeah, this is cool. Oh, this is working great. Look at it. Can you see that smoke? It's real. All right. So let's go and whoops. This is why you need a stand, because you can't just put this down right now or it will burn things up. And that would be very bad. So let's put it down and let's see if the automatic, oop, it's trying to get away. Let's see if the automatic, no, it's not turning off. I thought when I put it down it would cool down. Maybe that's a user setting. We definitely want to be able to turn that on. All right, so let's get the pins at least more or less adjusted. Good enough. We'll take the, kind of tilt the connector over a little, and oh yeah, this is actually really nice, I have to say. I've used quite a few soldering irons, and this one is pretty slick. I mean, for how small it is, I mean, that first solder joint is nice. Let's get the other one on there so that the headers for that don't fall off. So we'll just, felt like it moved a little. Yeah, we have to align it better now. If the pins are not correctly aligned, you will not be able to plug it in. Okay. That was a little too much. I don't have the best lighting here, but for this, I'll give another a light next time so that you can get a little bit better view. But and let's just straighten the other pin this out as well. All right, so let's go ahead and turn this off now. Which, how do you do that? I see. If I turn this down to, well, how do we turn it off? That's kind of key. Soldering settings. Let's see what those settings are. Boost temperature. There's a boost. Ooh. I don't want to boost it. Auto start. Temperature change short. I'm not sure what that does. Temperature change long. Oh, I see. If you want to like give it a boost for a period of time, like a quick boost or a long one. Allow locking buttons. I can't really tell what any of those do. I assume it's still quite hot though. You'll see it's definitely hot. You can see the smoke coming off. All right, I might have to read the manual, at least a little. So let's unplug it, which will of course turn it off, and let's let it cool down a bit. And while we do that, let's take a quick peek over here at the documentation page for this thing, which has quite a lot of information on it. So probably I could read the manual on here somewhere. Let's see. Go to store. No. Oh, there's a wiki. Excellent. Ah, yes, the wiki page. So it's got instructions here on how to use those soldering settings like the boost temperature and the auto start. Excellent. The user interface, advanced options. Here's some of the prototypes. Well, this is really cool. So let's go take a quick look at some of the other accessories that I got, which I did not want to take it apart and before I had the chance to at least try it and make sure it worked, right? I mean, if it didn't work and I had already taken it apart, I mean, I'm sure it worked out of the box, right? But this way we can be certain. So here is the pencil itself, which I don't know how hot it is. It cools off quite nicely. Yeah, it's really totally cool. Wow, that's really good. So it's got this tip that it came with. And then I also got a kit here that includes a series of other tips in case that kind of generic size is too, fat for you. You've got this really, really skinny micro tip. There's a chisel. I got the tips that were the fine tips as opposed to the thicker ones. I'm not going to use something like this to solder something that's too thick, probably. So I got my replacement or substitute tips. I've got the breakout board. So since this is in fact a programmable device, and we can perhaps at some point figure out how to get TinyGo to run on it. So that's what this is for, is this breakout board here is that way you've got pins for the debug connector and the OTA update. So I suppose this will probably be something you just plug into that back port. And then if we connect jumpers, we'll be able to program it using something like a JTAG connector, which is what is used to program some of the other boards. It's a very commonly used device. So that's really cool. We got this. This is just a breakout board. The actual processor is inside. And that brings up the third thing that I got, which is a transparent case. So, obviously I need to have not just, transparency is very important to those of us who work in open source. Haha, hee hee. And naturally, we want to be transparent in everything we do with electronics, like even the case itself. So yes, what I will do, not right now because I don't have time, and I didn't want to do this before because I'd like to do it together with all of you so we can actually check out how awesome this is going to look, is take the case off that it comes with. It's a cool looking black case. Don't get me wrong, this is really cool looking, but a transparent case where we can actually see all the electronics inside is just so much cooler. So that's what we'll do, is we will switch over to this transparent case, and I promise I will actually read the documentation so I know a little bit better how it is supposed to work. And then we can combine that information together to complete some of the soldering jobs for building some of the awesome stuff that we need to work on. So that pretty much wraps it up. It's been a really fun time. We've gotten to play with some toys. We got to do some machine learning with friend Manuel, who's been doing some really interesting stuff with cow vision. Really looking forward to seeing that in full splendor, if you will. And then Lorenzo was here, and we struggled a bit to try to get the Wi-Fi, which is part of the example, step 7, in the Arduino Nano 33 workshop. So it didn't quite work as expected. Got to do a little research into that to figure out why. And then had a chance to play with my new toy from our awesome friends at Pine64, the Pencil, which is a RISC-V completely programmable open source soldering iron. The ultimate in hacker chic. So on that, I will say farewell and adieu. It has been fantastic. And we will see you again next week for more fun at La Pipa, hacking hardware with Dead Program, myself, and GopherBot. Farewell, 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 farewell.
Computer distant, computer doctor, everybody that it does get flatter. Computer distant, computer doctor, you put it all on, put it all flatter. Computer distant, computer doctor, everybody that it does get flatter. Computer distant, computer doctor, you put it all on, put it all flatter. Computer distant, computer doctor, everybody that it does get flatter. Computer distant, computer doctor, you put it all on, put it all flatter. Computer distant.